Welcome to the Deep Dive. Today, we're wrestling with a text that fundamentally challenges how we think about the world,
It really does,
and
yeah.
specifically how we think about, the simplest things, like the number three.
Exactly.
We have in front of us a highly conceptual, very dense philosophical document. It's a thesis paper from a source called Beholm AG.
And I think it's important to say up front, this isn't a business plan or anything like that.
No, not at all.
It's a profound meditation on really the essence of mathematics, social structure, and the very origin of symbols. It forces us into a very different headspace.
It does.
We're moving far beyond practical arithmetic here. We're going to the territory of metamathematics and ontology, the study of being.
So what's our mission with this deep dive then? What's the goal for you, the listener?
I think our mission is to explore the foundational philosophical status of numbers and signs that this paper lays out. It asks these huge questions. What is the fundamental nature of certainty? How do we even communicate it?
And ultimately, that big question you see woven through the whole thing. What is the philosophical significance of the symbols we choose to represent reality?
Precisely. And it's a complete system, but it doesn't give you any gentle entrance.
No, it throws you right in the deep end. The document immediately assaults our most basic assumptions about calculation.
It starts with an assertion it's clearly designed to make you question the entire framework of linear thought.
Okay, so let's get into it. Thesis 1. The opening claim is,
Mm-hmm.
it's a jaw-dropper for anyone who's been to grade school. It says, 3 plus 3 equals 9.
Right. And then it clarifies, if you can call it that, by adding 3 times 3 also equals 9.
Which is correct, arithmetically, but the first part, 3 plus 3.
But you quickly realize, as you read on, that this entire segment is framed in the context of socialite, or sociality.
Okay. So this is not about apples or physical quantity.
Not at all. This is about relationships.
Okay, that changes things.
Exactly. The source calls this the kleine dreimal drei der Sozialität, which we can translate roughly as the small times 3 of sociality. The arithmetic is designed to illustrate a philosophical truth about human interaction.
And that truth is what?
That social combination is fundamentally non-linear. It's not additive. When you combine 3 units of friendship with 3 other units of friendship, the result isn't a simple sum of 6 people.
It's a compounded, multiplied outcome of 9.
Precisely.
It seems like a commentary on network effects, almost, but from a really philosophical angle.
That's a great way to put it.
If I have 3 friends and I introduce them to your 3 friends, the number of potential connections, the number of conversations, the potential for joy or conflict or whatever, it explodes beyond simple addition.
It does.
But why land specifically on 9? Why not 7 or, 12?
Well, 9 is chosen because it represents the pure square of that social unit, 3 times 3. The paper uses this perfect multiplication to define the qualitative game.
The qualitative gain, okay.
Yeah. And here's the core revolutionary insight. It says these 9 friends are friends because they experience neunfach mehr als nur zum neuntel sich erfreuen.
Okay, can you translate that for us?
It means they experience 9-fold more joy than just a 9th part of joy.
Whoa. Okay, so the output is not 9 friends. It's 9 units of intensified joy or well-being that's generated by the interaction.
Yes. The number is acting as a multiplier of a positive relational state.
So if you were just getting a 9th of the joy of 9 people, that would be simple addition, everyone just kind of existing in the same room.
Right. But if you're getting 9 times more than that theoretical baseline, it implies that the joy is emergent. It's spreading, it's compounding through the whole system.
And the source says this synergy is rooted in, what was the phrase?
The neunfache Freundschaft. My 9-fold friendship. The combination of 3 and 3 creates something entirely new, something greater than the sum of its parts.
This moves the number from being just a passive quantity to an active vector.
A vector, yes.
It tells us that combining social units doesn't just increase the head count, it increases the total potential energy of the relationship. It's an ontological claim, then.
It is a huge one.
The essence of Freundlichsein, or friendliness being, is exponential, not arithmetic.
And that is the philosophical significance right out of the gate. The paper is arguing that when you apply mathematics to human experience, you have to redefine the operations. A plus sign in a social equation denotes synergy, complexity, and emergent reality.
It sets the tone for everything that follows. Numbers here are not tools for counting things. They're descriptive metaphors for reality's deepest structures.
Exactly.
Which, if you follow that logic, if addition in the social realm means multiplication, we have to start wondering what subtraction means in that context.
That's a powerful and slightly terrifying implication, isn't it?
It is. Does subtracting 3 friends from a group of 9 cause the result to spiral down exponentially? Maybe back to 0?
That would imply an immense philosophical fragility in our social structures.
It shows the weight the paper assigns to these symbolic choices. If the rules of operation are qualitative, then all our actions have these compounded consequences.
It forces us to ask, what happens when we apply standard linear math to complex systems, social, biological, economic, and we pretend the result is only 6?
When the philosophical truth is 9.
We miscalculate the potential entirely. We miss the magic.
Wow. Okay, so once the paper has established that numbers have this incredible philosophical weight, it quickly tries to anchor certainty.
It has to, right? After blowing up something as basic as addition?
It does. So thesis 2 and 3, they define an unzerstörbar, an indestructible certainty. And that certainty is defined by 3 key German words. 1, Mather, 2, Hat, 3, Zahlen.
Mathematics has numbers.
Right, and you might read that and think, well, duh, of course math has numbers.
But the philosophical work here is done in the justification. Why are these 3 words foundational?
And the paper argues that these 3 terms are selected precisely because they are terms that one is capable of adding. So the creation of philosophical certainty relies on the fact that we can count the elements of that certainty. It's completely self-referential.
Absolutely. The certainty of mathematics is established by linguistic articulation, specifically using 3 words that can themselves be quantified. We achieve certainty by choosing definitional components that lend themselves to symbolic counting.
If you can count the elements of your foundation is certain. It's like an exercise in defining the boundary of knowledge.
And that's critical. That entanglement of language, quantification, and knowledge definition, it leads directly to the conceptual universe the paper is mapping out.
Which it calls the Numerikon.
The Numerikon. Thesis 4, it's defined as die Gesamtheit des Mathematischen.
The entirety of the mathematical realm.
Exactly. It's everything that supports mathematical thought. And you might initially imagine, a list of digits, 0 through 9. But the smurp is, it's vast.
It's the full symbolic toolbox. The paper lists not just mathematical numbers, but signs, verbal elements, symbols, the core operators.
Yeah.
Plus, minus, equals, greater than, less than.
And then it throws in something highly specific.
Upsilon, with a diacritic, and umlaut, the Greek letter upsilon.
Yes. And the inclusion of that specific non-numerical, non-operator symbol in the comprehensive definition of the mathematical universe it's deeply significant.
Why? What's it doing there?
Well, think about it. Why a Greek letter, and why that one in particular? It suggests that the Numerikon includes all forms of symbolic representation necessary for abstract thought, not just the ones we strictly label as arithmetic.
So it's not just about calculation.
No. Upsilon, in ancient contexts, often carried specific philosophical or phonetic weight. Its inclusion here implies that the boundary of the mathematical isn't confined to algebraic formulas. It extends to the very origins of symbolic representation.
It's acknowledging that even the choice of an alphabet or a phonetic sign contributes to the structure of how we build certainty.
Exactly. It confirms that the Numerikon is the entire grammar of certainty, not just the vocabulary of numbers. It's the scaffolding, the rules, the potential signs, the complete symbolic language we use to structure reality.
Okay, so that's the universe. Now we get to the paradox of dependence within it. The paper uses a simple fact. 1 plus 1 equals 2, but 1 plus 1 is unequal to 3. It calls that das Fakt, a necessary truth.
Right.
But then it asks, what happens if you try to pull the system apart?
And this is where the paper introduces a moral and an ontological argument for their interdependence. It's a brilliant way of philosophically justifying the relationship between structure and substance.
Well, let's start with the numbers themselves. Thesis 7 states that numbers without math would be gewissenlos.
Conscienceless.
I find that absolutely striking. What does a conscienceless number even look like?
Well, if mathematics is the set of rules, the logic, the constraints, then numbers themselves are just raw, undirected magnitudes.
Okay.
Imagine the number 5 existing purely as a quantity without the rule that 5 plus 1 must equal 6 or that 5 minus 3 must equal 2. It's just fiveness, chaotic, arbitrary, disconnected.
So it has no direction, no purpose.
No purpose. Mathematics provides the conscience. It dictates how numbers must behave. It gives them a moral structure, predictability, utility within the system. Without the conscience of math, numbers are simply chaotic potential. They have no prescribed destiny.
So math is the ethical framework that prevents raw quantity from running amok. And then the flip side, thesis 8, says that mathematics without numbers would be osuegos,
Hopeless.
hopeless.
It's structure without substance. Imagine having a perfect rule book, the logic of addition, subtraction, multiplication, but nothing to apply it to. No quantities, no magnitudes.
The rules are flawless, but they lead nowhere.
They're hopeless because they can't realize their potential. This establishes a foundational symbiotic relationship that the paper asserts can be proven.
Soger metamathematisch.
Even metamathematically, meaning it can be proven not just within the system, but by examining the system's own structure and its consistency.
This philosophical assertion is crucial for you, the listener, to grasp. Knowledge isn't built on numbers or rules, but on the inseparable, morally linked dependence of the two.
And this raises the question again, what is this rule system, this conscience? Thesis 9 makes a crucial distinction here. Mathematics is described as eine Sprache.
Not a language in the verbal sense.
Right, but fundamentally Zeichen and signs and symbols.
It feels like splitting hairs. If it uses signs and symbols and it communicates knowledge, why isn't it a language?
Because the paper elevates mathematics above natural language. It views it as something that is equivalent quasi-zentralistisch als Erkenntnis gesprochen.
Okay, that's a mouthful.
It is. It means it's equivalently spoken centrally as knowledge. Think about it. Verbal languages are regional. They're prone to ambiguity. They rely on convention and translation. Mathematics, through its signs and symbols, bypasses this ambiguity to articulate knowledge centrally, universally. It's a pure, unadulterated form of knowledge expression.
So language is the vehicle for communication. Math is the pure knowledge itself expressed through signs.
Yes. And yet, we perceive it through familiar forms. Thesis 10 notes that mathematics seems mathematical because it appears in recognizable linguistic forms. It's numbered, symbolized, written, and formulaic.
Formula compliance?
Formula compliant, using the agreed-upon roots and squares and operators. This is the convention we have accepted.
And a mathematician, by this paper's definition, is simply someone who recognizes and accepts this convention.
That's all.
They recognize the signs. They say 1 + 1, wir wissen Bescheid.
We know what's what.
We know it's what, and they are ready. They are initiated into the numericon.
And the philosophical significance there is that mathematical truth may be objective, but our access to it requires an agreement, a conventional initiation into its symbolic grammar.
The paper is subtly pointing out that the certainty we cherish is dependent on the symbolic choices we have agreed to uphold. The entire system of certainty relies on that initial, intentional act of recognizing and accepting the grammar of the numericon.
Which is a perfect transition.
It is. Because this leads us to the most profound ontological question in the entire document. Doch woher stammen die Zahlen? But where do the numbers come from?
If they're the raw, consciousless substance that's anchored by the mathematical structure, they must have emerged from something.
And the answers the paper provides are. They're wonderfully paradoxical.
Yeah.
It starts with the vastness of the natural world. It suggests numbers emerge from the infinite diversity around us.
From the things we perceive but don't yet quantify.
Right. It says they could come from posters, from meadows and forests, from flowers,
From distant and near stars.
and from every single raindrop. This seems to suggest that numbers are inherent properties of the universe, just waiting to be discovered.
It implies that the potential for numbering is everywhere. The vastness of the stars, the distinctness of every raindrop, these are countless, yet they exist in discrete units. It grounds the abstraction in the organic complexity of reality.
But then the source pivots.
It does. It pivots from passive existence to active creation.
It suggests numbers come from etwas und etwas, das Zählen gelernte.
Something that learned to count.
And that's the hinge point, isn't it? The transition from nature's potential to conscious, intentional human action.
It's everything.
The search for the origin of numbers then compels the paper to confront the concept of the infinite. Specifically, it references the apeiron.
The unlimited, the boundless, from pre-Socratic philosophy.
And what's fascinating here is the sheer audacity of the conceptual maneuver it makes.
It really is. The source asks, what if the apeiron is no longer unbekannt, no longer unknown?
If we accept that the apeiron is the unlimited, the human attempt to impose the structure of the numericon onto it must result in a massive philosophical conflict.
And the paper doesn't shy away from that at all. It attempts to quantify the boundless by assigning it numerical values.
Apeiron 1, apeiron 2, apeiron 3, A1, A2, A3.
Right there.
But wait, isn't the entire point of the apeiron that it cannot be numbered? By naming it A1, A2, A3, aren't we defeating the entire philosophical concept of boundlessness?
That is the precise philosophical tension the paper is highlighting. It's a conceptual act of domestication.
Domestication, I like that.
We are trying to impose the grammar of counting the intentional ordered structure of the numericon onto the absolute chaos of existence.
And this attempt to discretize the infinite leads directly to what it calls the one unimplicates.
Theorem.
First infinity theorem. The theorem itself isn't laid out, but the assertion of its existence is a claim that even the infinite can, through sheer symbolic will, be reduced to components.
A1, A2, A3.
Yes.
This implies that the human impulse to count, to categorize, to structure, is so powerful that it can override even the greatest philosophical concept of the unstructured. Our conscious decision to choose a symbol A1 is stronger than the concept of the absolute undefined.
It demonstrates the power of symbolic articulation. Once you assign a symbol, you've created a boundary, a definition, and a pathway for mathematical operation, even if that symbol points towards something that is inherently unquantifiable. So if the apeiron represents the vastness we're trying to structure, the paper then introduces the prenumericon. This represents the state before we chose the structure.
The Vorzahlanaartisch.
The prenumerical.
And the Vormathematische, the pre-mathematical.
The prenumericon is the ontological state of pure mathematical possibility.
It's the conceptual library where all mathematical rules and operations were merely latent. The paper describes it as a state where addition and subtraction were lediglich nach Potentialitäten waren.
Merely still potential.
Yes.
That implies a tremendous freedom. Before the rules were fixed, before we chose that 1 + 1 must equal 2 and never 3, all outcomes were merely potentials.
It's a huge implication.
The philosophical implication is that our modern mathematics is an extremely precise, rigid subset of an infinitely broader reality.
It's like an unwritten constitution where all legislative outcomes are possible, but none are fixed until the first intentional act of voting.
And the transition out of the prenumericon is described as nach dem Wählen hin zum Zahlenartigen.
After the choosing toward the numerical.
The philosophical weight is placed entirely on that act of Wählen of choice.
Everything hinges on it.
So, who was the first to choose? Who fixed the potentiality? And why did they choose 1 + 1 = 2 over, say, 1 + 1 = 3?
The paper raises those deep, almost metaphysical questions, like, what is the Klangjader Zahl?
The sound of every number.
Yes. It's asking about the inherent resonance or essence of a quantity before it was codified. The prenumericon is also called das Präzis, the precise state that existed before every number.
It is the raw, sharp, definable state of reality that preceded the blur of potential, which the act of counting then formalized.
It was a moment of tremendous philosophical and cosmic importance, the moment consciousness decided to bind itself to a specific set of symbolic rules.
And the paper connects us directly to consciousness.
It does. It explicitly links this origin of counting to fundamental consciousness. It mentions the punu, which strongly suggests pneuma, the spirit, breath, or consciousness.
And it questions Descartes' cogito ergo sum, I think. Therefore I am. It seems to imply that perhaps the foundational statement of existence is tied not just to thought, but to the capacity for symbolic structure.
Yes. I think, therefore I am, is replaced by.
I think I choose symbols, therefore I structure reality. The fundamental act of existence, according to this text, is the process of wählen und zählen von Zeichen und Symbolen, choosing and counting signs and symbols.
And this process is anything but simple. The paper describes the building blocks of this symbolic creation using these highly technical philosophical terms: combinable variables, optional signification theorems, meanings, verbal concepts.
But the most critical ones it lists are functional approximations initialen and optical differentials.
Yes.
Those sound like concepts straight out of a computational neuroscience textbook. How do those variables relate to the paper's argument that consciousness intentionally creates symbols?
Okay, let's break that down. Optical differentials refers to the subtle differences in raw sensory input, the way we perceive two raindrops as distinct, or two lines as parallel, even before we have a word for two, or parallel.
The raw data.
The raw data. The functional approximations initialen are the initial functional ways the mind attempts to approximate those differentials using basic symbolic placeholders.
So it's like the brain's first rough draft of a symbol.
A perfect analogy. Our brain takes the raw, chaotic input of the world and uses these initial approximations to begin formalizing it. This is the process that allows the mind to transition from seeing many things to defining 1, 2, 3.
And that makes the choice intentional. We're intentionally choosing a symbolic system, the numericon, to structure the raw material, the optical differentials that preceded counting in the pre-numericon.
Which leads to the paper's conclusion on this point. All these symbolic systems, the multiples, the numeration substrate, numerical substrates, are
not intrinsically
they're
instando.
not created unintentionally.
That intention is the key philosophical takeaway. Our mathematical universe is not an accident of nature. It is a deliberate, conscious construction by a self-aware entity trying to make the limitless apeiron manageable and the chaotic pre-numericon certain.
Mathematics is the supreme act of intentional symbolic articulation.
Okay, so we've established the origin and grammar of abstract mathematical certainty. Now the paper brings the discussion down to the physical world.
It has to ground it.
It does. It explores how this symbolic structure manifests in space under the heading Die Ästhetik der Architektur. It discusses polyästhetische und situative interactions involving buildings, paths, and people.
And this is all about how organized space creates symbolic stability. Architecture is the concrete manifestation of chosen structure.
Right.
When a place is built, the paper says it remains dem Ortgeschehen true. It remains faithful to the events that happen there. The arrangement of buildings and paths, what it calls architectural semantics, establishes an expectation of stability that guides human behavior.
The structure we impose on the city is the physical equivalent of the conscience that mathematics imposes on numbers.
What a great way to put it. Yes. If the numericon provides structure to thought, architecture provides structure to existence.
And the ultimate philosophical anchor for this physical certainty is what it calls the Stone thesis.
The Stone thesis is a wonderfully simple but powerful statement.
Stein bleiben Stein und Stein bleiben stable, obwohl sie unterschiedlich erscheinen.
Stones remain stones, and stones remain stable even though they appear different.
It's the constant within the variable. The surface appearance, the color, the texture, the shape, that's all variable. But the fundamental underlying essence, its stoneness, its stability, that remains constant.
And this mirrors the argument about numbers. Two numbers might appear differently, a root versus a square, but their underlying mathematical truth, their stability within the numericon, remains absolute.
This philosophical anchoring point is essential for distinguishing reality from illusion.
It is, and the paper quickly follows this with what it calls trivial truth that defies subjective interpretation. Die Illusion ist nicht von morgen, wenig ist nicht viel, Premium heißt nicht gratis.
The illusion is not from tomorrow, little is not much, premium doesn't mean free.
Right.
These aren't just bumper sticker slogans, they're presented as necessary certainties. If we cannot agree that little is not much, or that premium implies cost, then all economic, legal, and social interactions, they immediately break down.
And these certainties are anchored by the inherent stability of the material world, which is symbolized by the stone.
Which leads us to the final fascinating concept in the paper, the T-docs.
The trivial Wahrheiten der organisierten Chaotik.
The trivial truths of organized chaos.
Right.
Organized chaos.
Yeah.
That sounds like a contradiction in terms. But the paper suggests that even within a chaotic, unpredictable system, certainties must exist.
They are the philosophical non-negotiables. The paper argues that these Gewissheiten, these certainties, remain certain even for chaos. They are the ordinäre Relationen, ordinary relations, and the altbekannte Maßeinheiten, well-known units of measure that we take for granted but are absolutely necessary for comprehension.
Let's look at the examples it gives. They are incredibly basic yet profound in this context.
They are.
Warm and cold are opposites.
Or at least different sounds.
Right. And then localities or places.
Yeah.
Days and nights are different.
Let's take that first example. Warm and cold are physical phenomena, but the paper adds that parenthetical, or at least different sounds. This brings us right back to the symbolic articulation.
The optical differentials.
Exactly. We may perceive them differently, but we assign them distinct, opposing symbolic labels, which then allows us to organize that chaos.
And then there are the linguistic examples, like the homonymous sentences. Blau und weiß sind Worte. Blue and white are words.
This confirms the stability of symbolic meaning across different languages. Blue and white maintain their status as descriptive concepts regardless of whether you speak German or English. The symbolic function remains grammatical.
These trivial truths are the absolute floor of shared reality.
They have to be. And the philosophical conclusion of this segment is so powerful because it connects stability to emotion. It says, Ohne könnte keiner lieben.
Without these, no one could love.
Yes. Without these basic, shared, symbolic truths, complex human connection, like love, cannot exist.
That is a massive philosophical claim. Why do trivial truths enable love?
Because love and all complex human interaction relies on trust, on communication, on interpretation. The paper calls these trivial truths the necessary symbolic actions for the situative hermeneutik des Geschehens.
The situational hermeneutics of events.
Right. Hermeneutics is the theory of interpretation. To interpret a social event, to understand a gesture, a promise, a feeling, you must rely on a stable, agreed-upon context.
I see. So if I can't be sure that day is different from night, or that a building is stable, the stone thesis, how can I possibly interpret the meaning of someone's constant presence in my life?
You can't.
Trivial truths provide the stable environment necessary for the interpretation of complex, variable human behavior. They are the grammar for navigating social chaos.
If the symbolic systems were entirely unstable, if 3 plus 3 might equal 6 today and 9 tomorrow in a numerical sense, then the world is fundamentally unreliable. We need the reliable grammar of the numericon and the trivial truths to have the interpretive capacity required for trust, for predictability, for emotional investment.
The paper is essentially arguing that mathematical certainty is the prerequisite for emotional certainty.
I think that's the perfect summary of it.
Okay, let's try and unpack all this. This deep dive into the Bohme AG thesis paper has revealed a profound integrated philosophical system where mathematics and social reality are just intrinsically linked through the power of symbolic choice.
We covered 3 major philosophical movements within this single document. First, that radical redefinition of relational dynamics, asserting the multiplicative nature of social bonds where 3 plus 3 equals 9, transforming arithmetic into ontology.
Right. And second, the comprehensive structure of knowledge, the numericon, which defines certainty through a complete inventory of signs and symbols and assigns a moral structure, a conscience, to raw numbers, proving the symbiotic dependence of math and number.
And third, that ontological search for the origin point, the prenumericon. That state of pure potentiality that existed before consciousness made the intentional choice, the Weyland, to fix operations like addition and subtraction.
Moving us toward the numerical and the stable certainty of the trivial truths, anchored by the unyielding constancy of the stone.
The journey ultimately suggests that all forms of knowledge, from trying to quantify the infinite apron as A1, A2, A3, to recognizing that warm and cold are different, are bound by the necessity of symbolic articulation.
The entire reality we perceive is built upon the initial choice of a specific grammar.
And the paper concludes that grammar remains grammatical, always present in the event. So, if mathematics is the ultimate intentional grammar chosen to structure the universe, then we have to confront the central question this all leads to.
Which is,
how much of our perceived objective truth, that indestructible certainty we rely on, is simply a consequence of the symbols we deliberately chose when we abandon the state of infinite mathematical potential in the prenumericon?
wow, if addition and subtraction were once only potentialities, what alternative mathematical realities were lost when we fixed those operations?
Exactly.
Perhaps in a parallel universe, 3 plus 3 does equal 6 for apples, but 3 plus 3 equals 10 for joy. Or perhaps, as the paper might suggest, even 9 for sorrow. The fundamental nature of reality might be less about inherent truth and more about the absolute power of the first conscious symbolic choice.
And that is a weighty thought.
It's a very weighty thought to take with you today.